It is 7:34 p.m. The gym is loud, echoing with the clanking of iron, the rhythmic thud of dropping weights, the air heavy with sweat, chalk, and focus. To the outside observer, everything feels mostly normal. It is just another evening rush at the local fitness center. But deep inside the pectoralis major, things are about to go completely and utterly out of control. You are a muscle fiber. Not just any fiber, but a type 2 fast twitch muscle fiber residing deep within the sternocostal head of the human chest. Your existence is defined by one single purpose: to generate massive, explosive force. You sleep through the light tasks, ignoring the typing on keyboards, the carrying of groceries, the driving of cars. You only wake up when the demand for power crosses a critical threshold. And today, you have been recruited for a brutal mission. The human has chosen the bench press. The weight on the bar is heavy, intimidatingly heavy. The warm-up sets were easy. The blood began to flow, raising the local temperature of the muscle tissue, lubricating the joints, and preparing the neurological pathways for the task ahead. You felt the slight increase in tension, a mere stretching of your legs. But now, the working sets have begun. The human unracks the heavy barbell. The sheer gravitational downward force immediately compresses the joints and demands an equal and opposite reaction from the chest, the anterior deltoids, and the triceps. The first few reps were tough but manageable. As the bar descends, you undergo eccentric contraction, lengthening while under extreme tension. Then, as the bar touches the chest, the signal fires, and you contract concentrically, shortening and pulling with incredible force to drive the weight back up. During these initial repetitions, you burned through your readily available energy. The ATP stored within your cellular walls was depleted in mere seconds. To keep the engine running, your internal power plants started relying heavily on anaerobic glycolysis, breaking down glycogen stores without the use of oxygen. Because of this, it was getting hot. Lactic acid and hydrogen ions were building up rapidly inside you, making the cellular environment highly acidic, burning, and profoundly uncomfortable. The human feels this as the burn, a warning signal to stop. But the human pushed through. You survived the set, or so you thought. Just when you believed the ordeal was over, just when the tension was about to be relieved, you hear the worst phrase possible echoing down the nervous system, translating into a frantic electrical storm from the brain, traveling down the spinal cord, and arriving at the motor neurons. One more rep. You have already given everything you had. Your energy reserves are critically low. The acidic environment is interfering with your ability to contract efficiently. Your calcium ions, essential for muscle contraction, are struggling to bind properly. You are suffocating, burning, and exhausted, but the central nervous system does not care about your feelings. It does not care about your metabolic distress. It only cares about survival, and in this specific moment, survival means moving the heavy iron bar hovering menacingly above the chest cavity. The brain recruits every last possible motor unit, so you brace yourself. The tension arrives like an earthquake. The bar descends slowly, too slowly. The eccentric phase of this final repetition is agonizing. The mechanical load placed upon your structural proteins, the delicate and intricate actin and myosin filaments, is absolutely immense. They grab onto each other, forming cross bridges, pulling with all their microscopic might to slow the descent and prepare for the push. The bar touches the chest. The push begins. It is a slow, grinding, impossible struggle. The weight is simply too much. The tension is too high. The force required exceeds your current structural capacity. Suddenly, microscopic disasters start happening all around you. Snap, snap, snap. The sarcomeres, the fundamental contractile units of your muscle structure, are being stretched violently beyond their physical limits while simultaneously trying to contract. This creates a massive, contradictory shearing force. The delicate Z-discs that hold the entire structure together start to rip and tear. This is not a catastrophic major injury. This is not a torn muscle belly or a detached tendon. This is a microscopic battlefield. The fibers are entering a state of absolute physiological chaos. Micro tears are appearing across the muscle tissue. The physical damage is undeniably real, and the structural integrity of the chest muscle is being intentionally compromised. Your cellular membrane, the sarcolemma, is breached. The contents of the muscle cell begin to leak into the surrounding extracellular space. You are being sacrificed to achieve this impossible, agonizing repetition. Finally, after what feels like an eternity of grinding tension, the bar goes up. The human racks the weight. The mechanical tension instantly drops to zero. The set is over. The human has reached absolute muscular failure. But the chaos inside the pectoralis major is just beginning. The immediate aftermath is a state of severe biological emergency. The micro tears in your structure, and the breached cellular membranes have caused a localized crisis of epic proportions. You and the surrounding damaged fibers release a chemical distress signal into the surrounding fluid. This is the inflammatory alarm. Chemical messengers, particularly cytokines like interleukin-6 and tumor necrosis factor alpha, flood the area. They are the body's molecular sirens, screaming for help, alerting the entire immune system that the chest has taken significant structural damage and requires immediate, urgent intervention. Within hours, the site of the micro tears transforms from a battlefield into a highly active construction zone. Blood flow to the pectoralis major increases dramatically. The blood vessels dilate, bringing a massive rush of fluid, oxygen, and crucial nutrients. This localized swelling is what the human feels immediately as the pump, and later, as the infamous delayed onset muscle soreness, or DOMS. The area swells significantly. It becomes tender, stiff, and painful to the touch. The first responders arrive on the scene almost immediately. These are the neutrophils, the rapid reaction force of the immune system. They quickly assess the damage and begin the initial containment. Shortly after, the heavy machinery arrives. These are the macrophages, highly specialized white blood cells. They act like a microscopic, aggressive cleanup crew. The macrophages sweep through the damaged tissue. Through a process called phagocytosis, they literally eat and remove the broken fragments of actin, myosin, and torn cellular membranes. They clear the wreckage, removing the dead and dying cellular debris to make way for the rebuilding process. It is a harsh, highly acidic, and inflammatory environment, but this inflammation is not the enemy. It is absolutely necessary for what comes next. Without this cleanup, rebuilding is impossible. With the debris cleared by the macrophages, the environment shifts from destructive to constructive. The cytokines change their tune, signaling for growth and repair. It is time for the reinforcements. Enter the satellite cells. These are the true, unsung heroes of muscle growth. They are specialized, dormant stem cells that lie quietly on the outside of the muscle fibers, sandwiched beneath the basal lamina. They spend their entire lives waiting for a crisis exactly like this one. The inflammatory alarm, specifically the release of certain growth factors, wakes them from their slumber. Once activated, the satellite cells multiply rapidly. They divide and rush to the specific sites of the micro tears along the damaged muscle fiber. What they do next is extraordinary. The satellite cells fuse directly with the damaged muscle fibers. They do not just patch the microscopic holes like simple glue. They actually donate their own nuclei to the muscle fiber. This is a critical biological maneuver because muscle cells are unique. They are multinucleated. They can have hundreds of nuclei within a single cell. Why is this important? Because the nucleus is the control center. It holds the DNA blueprints. More nuclei mean a significantly greater capacity to manufacture proteins. By donating their nuclei, the satellite cells are permanently upgrading the manufacturing capacity of the muscle fiber. Now, the cellular factory goes into absolute overdrive. The process of muscle protein synthesis begins. Inside the newly upgraded muscle fiber, the ribosomes read the genetic blueprints provided by the messenger RNA. They start assembling new proteins, meticulously connecting amino acid by amino acid in a complex chain. They build new, stronger actin and myosin filaments. They weave these new contractile proteins into the damaged areas, repairing the torn Z discs and reinforcing the sarcomeres. But the human body is remarkably smart. It is an adaptation machine. It does not just repair the muscle back to its original baseline state. The body perceives that one last grueling repetition, that intense mechanical tension that caused the damage, as a severe threat to its very survival. The biological logic is simple. If we face this heavy load again with our current structure, we might be destroyed. We must adapt. So, the body overcompensates. It builds the muscle back thicker, denser, and fundamentally stronger than it was before the workout. It adds more contractile proteins, adding them in parallel, which increases the physical cross-sectional area of the muscle fiber. This remarkable process of adaptation and growth is called hypertrophy. The chest muscle literally grows larger and more powerful to handle the extreme stress it was subjected to. This complex rebuilding process takes time. It is not instantaneous. It requires 24 to 48 hours, sometimes even up to 72 hours of rest. It requires plenty of water to facilitate the cellular processes, and most importantly, it requires a massive, consistent influx of protein from the human's diet. Every piece of chicken, every scoop of whey protein, every egg the human consumes is broken down in the digestive system into its fundamental building blocks, amino acids. These amino acids are absorbed into the bloodstream and shipped directly to this microscopic construction site in the chest. They are the raw materials used by the ribosomes to build the new muscle tissue. If the human fails to provide enough protein or fails to sleep and recover, the construction halts and the muscle cannot grow. As the days pass, the intense soreness begins to fade. The swelling goes down as the inflammatory response subsides. The new proteins are fully integrated into the existing structure, and the chest muscle is now officially upgraded. The structural integrity is massively reinforced. The individual fibers are physically thicker. The capacity to generate force has mathematically increased. The mission, despite the temporary chaos and damage, was an overwhelming biological success. The muscle has adapted. We will return stronger. Because knowing this crazy human and hearing the alarm clock set for another gym session, this loco is surely coming back tomorrow to do it all over again.